All right, we give thanks to God Almighty for this day and an opportunity for us to look at experimental design. We ask for His guidance, we ask for wisdom and knowledge, and whatever we are going to read through and learn, we should be able to understand it. This is our prayer, and we pray that God answers our prayer in Jesus' name. Amen. And now we start. All right, this textbook I downloaded did an analysis using spaces, even though we have no intention of going to look at all the things that are how to use SPSS. We are interested in analysis, in the analysis, which we will use to explain some of the things that we've been discussing in our class. All right, this is a sample of an analysis where a set of data was given, and in this data, a particular variable called age. Miss Rukaya, I hope you are with me. Are you there?
Yes, sir.
All right. Like I said, we don't want to study how to use spaces, but I needed us to go through this sample of analysis so we can get to understand it. Do you know how to use SPSS?
No, sir, actually, no.
Okay. I mentioned it, was it last class, that anybody who wishes, you can post it to a group. Somebody might take on the class. Okay, I'll post it and ask that somebody should take on a class on SPSS.
Okay, that would be nice. Thank you, sir.
Yes. I want us to look at this sample of data.
Okay.
This is how a data set looks like. Now, this is not the data that they are working on. No. This one I downloaded this so we can play with during this one of our classes. So we can play with this data. So I downloaded it to keep for future purpose. We may work on it within the week, as in next week, sorry. But we need a better time for us to go practical. Now, this is how data is being tabulated. This one is being tabulated on Excel. Now, before this data was gotten, we will go to how the data was gotten. But I want us to look at something. So each of these columns is called a variable. Like this, I hope if you can see this very well. This column B has a variable age in years. This column C has a variable called gender. This column has a variable called maximum educational level. The several variables collected in the data. Now, this is a typical data set. Now let's go back to what this analysis is about. Now, in this analysis, this ID can be serial number. It might not be useful in the analysis. It's like saying serial number 1 to 1,000, 1 to 1 million. This school year group is, what do you think school year group, which kind of data, what kind of data do you think it is? Data type. I say, were you there when we discussed data types?
No, sir. I just joined the last
Okay.
class.
All
Yeah,
right.
so I am
School year.
actually very new.
Okay. School
Sorry.
year in this data set. Okay, let me use this to do the explanation so that before we go back to that. Now, this is a data set. This participant number can be said to be the ID, like presented here. I hope you understand that particular one. Then
Yes.
this age in years, okay?
Yes.
Age, is it a discrete or continuous form? Is it in discrete or continuous form?
Is in continuous form.
No, it's a discrete, it's in discrete form
Okay.
because either the person is, nobody is 22.1 years old.
Okay, yeah, I understand. Yeah.
It's in discrete form.
Yeah.
Yes, so it is not in continuous data. So
Mm.
even though the data type in this age is presented as how do I call it? It's presented as numbers. So we have the continuous and the discrete numbers. So in this case, it's presented as a discrete set of discrete numbers. Now, this gender, what kind of data type is it? Hmm?
Also a discrete.
No, it's a categorical data. Okay,
Oh,
we have to go back to
okay,
data
I
for this one.
understand. Okay.
So
Maybe, yeah,
you have
I
the
understand.
numeric, we have the categorical, and under the categorical, under the numeric data, numerical data, we have the continuous and the discrete. Under categorical, we have the ordinal and the nominal data.
Okay. Okay.
Then in under in yes, we have the ordinal and nominal data.
Phenomenal.
In this case, the difference between the ordinal and nominal,
Yeah.
ordinal data has to do with groups that can be
Okay.
ranked, that can be
Okay.
ranked either in ascending or
Or descending.
descending order. Then
Okay.
nominal data refers to categorical data that cannot be ranked. You can only group them
Okay.
differently, but one is not higher than the other.
Okay.
So what kind of data type is gender in this case? So, are you there? From what I've just said, what kind of
Yeah.
data type?
It's a categorical, it's a nominal.
Very well, it is nominal
Yeah.
because male does not rank higher than female.
Higher. Exactly, sir.
It's nominal data.
Yes,
The
sir.
maximum educational level, what kind of data type is it being presented?
Categorical but ordinal.
Ordinal. Very well, that's very good. Because in this case, we have
Mm.
professional training, we have
Yeah.
postgraduate,
Yeah.
we have high school. So you
Yes.
can rank.
Yes.
Then we have handedness. What kind of categorical data is it?
It's a nominal.
It's nominal because right hand is not bigger than left hand. It
Exactly.
all depends on the person. Is
Yes,
the
sir.
person right-handed or left-handed?
Yes, sir.
Yeah. Percentage, is it a numeric or categorical?
Yeah, it's a numeric.
Yeah, yes, numeric.
Mm.
And what kind of numeric does percentage for?
Um,
In this case,
yes.
it's a discrete number that is how the
Okay.
yes, all the percentages are presented as discrete.
Okay, but percentage can't it be like 50.5%?
Yes, it can, but this
Mm.
particular data did
Yes.
not present them in
Okay.
continuous form.
Okay. All right.
Yes,
I
they
got it.
presented them in discrete
I got
form.
it. Okay, I got it. Sir.
Yes. All right. Now let's go back to this sample of analysis. So the person got that set of data, the set of data in that form.
Mm.
You understand now?
Yes.
Now, when this thing is being imported, like they are using SPSS, being
Yeah.
imported into
Mm.
SPSS, this is
Yeah.
how the variables, the columns will be. The
Okay.
columns will be here. You see the
Okay.
ID, like the ID representing this participant number. Understand?
Okay.
Yes, the school year group in their own case, the
Okay.
region. So this school year group has to do with ordinal data,
Okay.
is region of residence has to do with nominal data,
Yes, sir.
gender is nominal, frequency of sunscreen. That is what they were calculating. It's a categorical data, but they converted the categorical data, they counted it. After counting, they presented it as frequency. So now,
Okay.
a typical example is that we can find the frequency of the people who are 22 years old, frequency of people who are 21, frequency of people who are 30. But you can also group them. When you group them, they become this age in years. Is it if it is grouped into ranges, how will it now become? What kind of categorical data will it become?
It will be ordinal.
To become ordinal,
Yes.
because once you group them by
Yes.
ranges, one will be of a higher age
Yeah.
than, so that's it. So after they grouped their own, they now came up with frequency, and they had frequency of sun art. frequency of sun glasses. Grouping according to the research they were doing. Probably they were checking how people use eyeglasses. So there is sunscreen, there is sun art. Sorry, how people use things to protect them from the sun. Maybe some people use sunscreen on their skin. Some people use sun art to prevent their age. Some people use sunglasses. So now, for us to understand each of the data, we can pick a variable. In this case, they picked the age out of this group. That is why it is not listed here, so that they can check the frequency table of the age. So they want to see if the age follows certain distribution. So now, when they were analyzing the age, you can analyze the gender, you can analyze the age region, you can analyze the school year group, you can analyze anyone to see how it looks like. So in analyzing it, this is what they had, that for those who fall under age 11, this is the number of response they had. 59 people responded. Are you seeing the screen very well? Let me increase it. Out of a total of 664 people that responded, 59 people were 11 years old, 111 people were 12 years old, 257 were 13 years old, 177 were 14 years old, 30 people were 15 years old, 5 people were 16 years old, 1 person was 17 years old. People did not give their age. Are you able to get up to that point?
Yes.
Okay. This is a simple analysis of response in a data set
Yes.
of a particular variable.
Okay.
Now, once they get the frequency, they can calculate the percentage. It is computerized, it's computerized, but I'm telling you how to read whenever you
Yes.
see an analysis, how
Okay.
you can understand what the analysis is saying. So it's also saying that this is the percentage of each of the people that responded according to their ages. And you notice that the age in this case is presented in discrete form, not in continuous form. They are not ranged too, so they are not under, what do I call it? They are not under um, ordinal in this case now. They are presented in discrete form,
Yes.
in numeric.
Yes.
So they are not trying to rank it.
Yes.
They just want to analyze the ages, how they responded. So this is the, after getting this point, this next column that has to do with valid percent is that they now dropped this missing people, people that did not give their accurate age, these 6 people. By dropping them, they now adjusted the entire percentage. Do you understand to that point?
Yes.
Yes, that one that has valid percent. Now,
Yes.
reading the next column that has to do with cumulative percent, they now readjusted and took out not by taking out, sorry, not by taking out any data. They readjusted by doing cumulative percentage to see. Do you remember you did something about cumulative frequency in your
Yes,
history?
yes,
Yes.
yes, yes.
So you did cumulative percentage. So the cumulative
Okay.
percentage starts with the lowest, the first one, sorry, not the lowest. The first one was 9.2. So you take 17.3 and add with 9.2, and it will give you 26.6. You understand? Up
Yes,
to that.
yes, I
Then
remember.
you
Yes,
take and add until you have this 100.
yes,
So that is for that analysis. Then they now decide to present it again in in histogram to see how it goes. You can notice that there are 1, 2, 3, 4, 5, 6, 7 histogram beams. But one is so flat. So which means the histogram is tilted at the right hand side and skewed to the left. You notice that.
yes,
So the histogram does not give us a true picture if it is normally fully, as in a normally distributed data, if the data is normally distributed. So let's see how they summarized their analysis here. They say from the bar chart, we can immediately make observations like most respondents are age 13. Yes, they responded with the highest frequency is 13 years old. So mostly 13-year-old responded to that research. So that's it. So they have scale variables. All right. Now, this is another set of data. This is another set of data. I think this data has to do with pulse. Which is the dependent variable. So they check the pulse of people who do, how do you call it, athletics. So people that ran, they took the pulse of people that smoke, they took the pulse of people, okay, people that ran, people that smoke, and collected their gender. They took their height, their weight, their activity. Maybe people that ran also smoke, or people that smoke also ran. It all depends on the responses. Some people that ran may not be smokers, and some people that smoked may not have participated in the running. You understand? But that is not the idea. The idea is the data set was obtained. So now the pulse is a dependent variable. The idea is to obtain the pulse of the people. Is it after they are running and smoking, or after they are running or smoking, whichever kind of data they obtained? So this is how they presented the data. So this is the pulse rate. This is how you read. Now the mean pulse is 72.87, and the standard deviation is 1.148. So in this case, it's tending to, it's trying to tend to normal. distribution, if you look at this standard deviation. So let's see if the lower bound and the upper bound of, of the mean. Let's look. Okay. Lower bound is 70.59. The upper bound is 75.15. That is the lower bound and the upper bound of the mean deviation. That is what is being used now. Now, 5% shrink mean has to do with 72.63. The median is 71. And the variance, this is the statistics obtained, the variance, the standard deviation, 11 point something. The minimum of the pulse is 48. The maximum of the pulse is 100. The range is 52 between the minimum and the maximum. The interquartile range is 16. So, which is the lowest quarter and the highest quarter, the difference is 16. Then the skewness is 0.39. Then the cutoff is negative. The skewness is positive, and the cutoff is, I talked about skewness has to do with it being at the tending to the middle, having equal parts. So the skewness is low, which means it's tending to the left and not to the right. Then the kurtosis has to do with the tail, which means the tail is negative, it's not very flat. It's not close to the, but as in the baseline. So this is just a rough reading of the pulse. So at least looking at this data, we can read the statistic there and understand what they are trying to talk about. And we can also see the standard error and the standard error of the skewness and the cutoffs. You can see the skewness is low, tending towards the left, and the kurtosis is that the tails are not close to the baseline. They are up, understand? They don't go down. So it is not normally, it's not a normal distribution going by this presentation, because for it to be a normal, the skewness must be closer to 5, 0.5. You understand? And the kurtosis must be closer to, kurtosis must be closer to 0. Do you
Yes.
understand? Yes.
Yes, sir.
So that is how to read. So those are very important things. So if it is closer to 0.5, you know that it's tending to a normal distribution. So supposing it was 0.45, like something like that upwards, then the kurtosis, if it was lower, 0.0 something or 0.1, then you know that it tends to a normal distribution. So those two. So this is a rough reading of this particular analysis. So we can say that this data, you can not say this data is obtained from a normally distributed population. So, which means it is just a sample data. You need to obtain several other sample data for you to be sure that the data is normally distributed. Now, whatever you obtain from the data is a true representation of the population. So which means this data is just a sample of a population. You understand now? So let's see another sample for us to read so that we can understand. There's something else I intend to explain to us before we even hope to do any practical. But let's just go through these notes. The reason I'm skipping some of these things because they have to do with SPSS. So we will, since we are not looking at studying SPSS, we'll skip this. Trying to see analysis that we can read to our understanding. Let's look at this analysis. Okay, I think it's the same thing. All right. Okay, this is test for normality. Okay, there are different kinds of tests of normality. They have the independent t-test, we have the paired t-test, we have the one way ANOVA, repeated measures, and there is, these are parametric measures, parametric tests. The independent t-test tests only a particular variable. The paired t-test compares two variables. Then this is how the paired t-test compares two variables. In the case of independent t-test, we can test gender, between gender. In the case of paired t-test, we can test the same gender, but in two different conditions. Are you with me?
Yes.
Okay, let me repeat that. In the independent t-test, you can test genders, knowing that you have two different genders. That's that.
Yes.
So, but in the paired t-test, you can say one gender, male, but you want to test them in two different conditions. Either when somebody is 10 years old or somebody is 15 years old, but the same gender. You
Mm-hmm.
can also test when somebody did something in this condition,
Allah mutumin nan da ya mutu ma rai.
between one town and the other town, that is paired test. You understand? When they were in
Yes.
this town and when they were in the other town, the same set of variable, how do you call it? Yes, variable. Understand? Testing
Yes.
them in different conditions. But when it has to do with independency, it has to do with separating them in um, nominal form. You understand? You are trying to see if their nominal roles affects their performance in that particular analysis. You understand?
Yes.
Because in the paired test, you want to see if their conditions, one condition superimposed as it affected the, the results, the observation. So you are trying to um, categorize them into ordinal. Which one is higher? Which one affected it more? That is why paired t-test comes in. That is why we have paired differences. So if you are in Abuja, how does it affect you? Supposing you now leave Abuja and go to Lagos, which will affect you more? That is paired t-test. But if it has to do with the group of people in a nominal form, gender, how it's affecting the male and the female in Abuja, or the male and the female in Lagos, you apply
Yes.
independent
Hmm?
tests.
So
You
are you saying
understand?
is it petty test?
You
Oh,
understand that
peer
one
T
now?
test. Yes.
So one way ANOVA can be applied on any data that it has one variable, We have repeated measures ANOVA. So it is what you use in checking the abnormality. In the case of independent t-test is that dependent variable by group. So if a male is more, it contributes more to the dependency, or if the female contributes more to the dependency, then the petty test, you are checking how different are they. Supposing you want to check only the males, how does it affect only the males in Lagos compared to if the males goes to Abuja or the males in Abuja? Understand? So you
Yes.
want to find their differences. So our differences will check if they are from a normal, will tell us whether they are from the normal distribution. If it
Okay.
has that 0.5 skewness, close to 0.5, you know it is close to normal. And the kurtosis has to be so very low too. So you now use to check. So those are things you look at depending on the test you are using. Why do I explain this test? It is the kind of data you have that will tell you which test is suited. The independent t-test is mostly when you want to present them in ordinal form. You want to see
Yes.
which of the ordinal data contributes more. Then
Yeah.
the t-test is a particular group. How do they fare in different conditions? Then you now apply paired t-test. Then one way ANOVA, you can use any of the data to do one way ANOVA. You can use it to do measures of repeated measures ANOVA. You can use it to do Pearson correlation. You can use it simple linear regression. So I think I've been able to explain that in case we get to example. This is a typical data that skews to the left, like that data we just saw.
Okay.
So this one talks about skewness and hypothesis in explanation. We are not reading the explanation. Remember during this, we talked about the Q plot. You can observe this plot, the shape is not following a straight line.
Yeah.
It looks like it is close, understand, but it's not giving you a true normal data.
Okay.
So there is this analysis here. They are showing us how to use SPSS to find a QQ plot of a particular data set, a variable of a particular data set. So this is the pulse, and this is the shape of it.
Okay.
So this is the shape. Let's look at another analysis they did here. Like this is the gender now. Now, this is a typical data that you can apply the test of dependency, the t-test. How did we call that t-test? The independent t-test, yeah? I hope that is how to call it.
Okay.
The independent t-test.
Independent.
This is data you can apply. So now, when we want to group them into male and female, so yes, you apply independent t-test because each of them you want to see how they contribute to the dependency, the outcome. So this is a typical. Were you there when I discussed box plots? Were you there in that class? Okay, I talked about box
Box
plots.
plot. Yes.
Yes,
I followed the lectures. Yeah.
yes. We talked about box plot. So each of the variable in this particular data set, I don't know why this is blurry.
Okay.
But they presented this in the box plot according to gender, male and female. So for each of the population, I don't know if it is by age, looks like it's by age, between those who are about 16 or 17 years old
17. Yeah.
to those who are higher,
Yes.
up to 20 something. So they now put their BMI, body mass index, the minimum, the maximum. Then in between them, inside the box, we have the first quarter, the interquarter, and the third quarter. You notice their shape. You can notice that this one, the first one, the blue box of the male, that the median is very close to the first quarter, which means the difference between the people that fall into this third quarter are low. They are not much. So you can easily read this data and know that those who have this BMI, who are male, who are of this age range, can now say that you can say that their median falls in around 23 or so. So you can read for this particular group, you can read for this particular group. I would have loved to see, but I'm not seeing this particular thing is blurry. I would have loved to understand what each of these colors stood for so that I'll be able to read very well. If it is for those whose BMI are low or high. So that's just how to read the box plots. You can see in the case of the female, the blue box. If you see the median of the blue box is more centralized. And even the ash color box, for each of them, the median, both the male and female, their median are more centralized. So you can easily read the median age of those having that BMI. So I hope you understand. So you can easily read their median age. So you can even easily predict that people have that median, probably that BMI for, in the case of a male, for under 23 years old, for within 23 years, you can easily make a prediction of facts because your data is close to being correct. The same thing with female. I think we are going to round up here. Let's not move to this other one yet. We'll continue tomorrow. There is something else I would love to show us. That one has to do with how to design, because we talked about design of experiment. So I wanted to see us to show us a sample, but let's finish this. So tomorrow, when we finish this, I'm going to show us a sample question that
Okay.
came up with certain set of data. This set of data that I showed, a sample question. So
Okay.
most of the questionnaires people do because they just do it for their projects actually are biased because they ask direct questions. So we will look at a sample design, a questionnaire design that's suitable for experimental design. And you now understand that most of these things we are doing online, that we think we are just working online, that people are obtaining data from us every day. Like when you know these things, you know that you'll be careful whenever you are online. So I'll show you something. So this will end our class for today.
Okay.
We'll continue tomorrow. Thank you for coming around.
Thank you very much, sir. I'm grateful. Thank you, sir.
Thank you. Thank you
Yes.
very much. Thank you so much.
I know we are not of the same faith. So that is why most times when I ask somebody to pray, it might be uncomfortable.
Sorry.
But I say I understand that we are not of the same faith. So it might look awkward asking.
Yeah, I understand.
Whatever the case, we always give thanks to God and
Yeah.
pray that whatever we learn, we are able to understand it.
Yeah.
Thank you.
Yes.
Thank you, sir. Thank you, sir. Thank you.
So thank you very much, sir. Thank you so much.
Welcome.
Yes, thank you so much. Okay, see you tomorrow.